Vanakkam. So we will continue our lecture on engineering seismology. So last class we have been discussing about the seismic zonation map of India, and also we talk about the microzonation of Bangalore. So how the systematically the microzonation has been done, and we also looked at that what are the essential component which is basically decided based on the city. Okay. So you will not get all the earthquake hazard parameters similar throughout the country. So if you are the coastal region, you will get different earthquake hazard parameters. If you are in the hilly region, you will get different earthquake hazard parameters. You are in the middle of the any of the part of India, then you will get different earthquake hazard parameters. So which has to be systematically geomorphological attributes and seismological attributes. So the geomorphological attributes, we have seen that the soil thickness, okay, so the topography, rock type, geology of the material, water bodies. So these are all the geomorphological attributes. One has to basically consider and estimate systematically and then weigh them accordingly, give the weightage. Okay, so considering the importance of that particular factor to contribute to the final seismic hazard in the region. Then the another parameters seismological attributes, which is basically function of earthquake. Okay, so the direct ground shaking, amplification, as well as the liquefaction, and then predominant frequency. Okay, so then the landslide, tsunami. So these are all the seismological attributes. So all these parameters needs to be systematically estimated. Each parameter estimation is a crucial role. Okay, people has to have the expertise. It is not possible to estimate just like that, but for the mapping purpose I have shown you that parameter and described like how those parameters are estimated. But in general, so each parameter estimation requires the in-depth knowledge of that particular parameters, how is associated in your region and past history, all those things you have to consider and then take that parameter and estimate precisely and map it. So if you map all those parameters, geomorphological attribute and then seismological attributes, then finally you can integrate all of them in the GIS platform. We have seen that GIS has a unique opportunity to integrate, okay, and then like handle the data, analyze the data, like multiply, add, divide. So all those things are possible in the GIS platform in tabular form as well as the graphical form. So you can do that calculation and finally produce hazard index map. So that hazard index map can be estimated deterministically as well as the probabilistically. So deterministically means it is the worst scenario in the region. So that is that, beyond that there is nothing you can expect. So that kind of worst scenario is the deterministic approach. Okay, the probabilistic is you will specify what is the probability of exceedance in the given period. Generally they take 50 years. The 50 years basically the building life of the any normal building. So in that 2% probability, 10% probability, 50% probability. So like that you can divide that into different probability and estimate and map hazard index for this estimation, that is called as a probabilistic seismic hazard index map or seismic microzonation map of the region. So this is how you can map. So we have also discussed that the Indian code. Okay, so we have seen that the first version of the Indian code was released 1962, then it has been subsequently updated on the 1970, okay, 1984, 2002 and 2016 with a gap of roughly more than 10 years. Okay, so we have seen that, but most of the update, okay, so only people added the new earthquake location as a severe zone. Okay, so this Indian code basically arrived based on the past seismicity in the region or experienced intensities at the region. Okay. We can also here think that the intensity experienced, intensity predicted, there is a two difference term. Okay. So the intensity experienced means based on the past earthquake, okay, based on the observatory from the people or from the damage, scientist went, geologist went, seismologist went, they collected a data and they noted down what is the intensity as per the intensity scale what we have discussed earlier. Okay, that is the intensity observed. The intensity predicted means there is a intensity predictive equation for the region based on the observed data. then that intensity predictive equation is used to estimate a intensity values and mapped. Okay. So, these two are the different, but Indian code based on the past observed intensity, not the predicted intensity, that is also we should know. And we also discussed that these intensity values are converted as a PGA. Okay. So, during 1984 or 2002 version, so where they consider intensity and PGA conversion, and they are given in the form of zonation factor. Okay, that each zone is. So, currently India has a totally 4 zone. Earlier the South India, most of the South India was first version, it was a 0 zone, then became a zone 1, then now most of the lowest zone expected in India is 2. So, which indicate that our understanding, okay, and our prediction of earthquake is not so accurate. Okay. So, that is why these zonation maps are keep updated frequently after the earthquake, not based on the predicted values. So, even though there are here and there some studies are done by the experts, like we have seen that macro zonation was done by the Nathan Timbajam and the NDMA, they released the probabilistic seismic hazard map of the India in 2010, but all these maps, what happens actually, there was the consistent the inaccuracy because of the model what they use, the parameter what they consider, the result what they deliver. So, the group of scientists or the people who are in the country not unanimously agreeing that this is the best way to represent. Okay. So, we also seen that the Indian code provided a response, okay, spectrum or a design spectrum which considers basically the acceleration velocity and displacement sensitive region. When we are talking about the response spectrum and tripartite plot, I told you that this shape, the cutoff period for the acceleration sensitive, velocity sensitive and displacement sensitive depends upon the recorded data at the region. As on my knowledge, okay, so as per also the literature what I have gone through, our spectrum what we use actually 99% may not be derived from the past earthquake recorded in the India. Why? Because the spectral shape, okay, so we gone through the literature and found that it was actually the Newmark and all spectral shape which was based on the some western countries earthquake. Okay. So, if you are interested in doing research on that, that is one of the potential area you can consider and contribute to that. So, by considering that and also the current spectrum, okay, we have 3 classification, okay, where the basically the velocity and displacement regions are divided as a are shown a difference for the rock or very dense soil, medium soil or loose soil, not on the acceleration and velocity portion. Okay. So, that also is a another concern. If you look at a modern seismic code, okay, if you want to see the modern code, just type Google, find out a design spectrum of International Building Code IBC or Euro code. Okay. So, all those code if you see, they are given design spectrum shape, okay, based on the different soil classification which accounts the acceleration region, velocity region and displacement region. Right now our code does not account that. We also seen that until 2016 our code is silent about the talking about the liquefaction. There is no discussion on liquefaction until 2016. Okay, that is 2016 version, they are given a liquefaction estimation a part of the code, but still the procedures and methodology given, okay, is actually borrowed from the foreign countries without verifying that it is applicable for Indian scenario or not, but at least it has been incorporated. That means, people who are designed their building before 2016 may not be considered liquefaction as a part of assessment in the building construction. The code also categorically specifies that any important buildings such as a tall structure, multi-story buildings, dams, nuclear power plant, okay, bridges, site specific study has to be taken into account and the minimum value given in the code should be considered as a minimum value. The zonation factor given in the code should be considered as a minimum value in case if you get the lower hazard. So, that is what code specifies, but most of the apartments, okay, in the many of the urban cities including Delhi, Bangalore, Mumbai and all, nobody does site specific consideration for the design of structures. It is very unfortunate, particularly why it is very important, because these are all the apartments the large number of people live. Okay, so in the order of like 5,000, 10,000 people live at a small area. Okay, so which has to be accounted because it's together like 4 or 5 villages if you count the size of the Indian village typically. So which has to be safe. Okay, and also these structures are multi-storied. Multi-storied means like so minimum 10, 15, 20, 25 kind of things. So where the huge carpet area like floor area has been covered. So which is always has a potential for any small disaster can trigger a massive financial and a fatality loss. Okay, so in order to prevent that, this building should be safe against any natural disaster. Okay, so there was again I was also keep telling that there was a tremors in Delhi. Even during this courses we have been telling that even yesterday even there was a micro earthquake has been reported in the NCR Delhi. So I am not very sure to comment critically that it is a potential for the big earthquake or not potential for the big earthquake, but it indicates that we should do some kind of precursor study or a prediction study. We have seen that the VP VS ratio, okay, will change before earthquake and during the earthquake. So that kind of indication people can do, and also they can try to see the any geological evidence in the past and match with the present epicenters and try to pinpoint which location it ruptures. Okay, so then based on that there is any associated nearby fault. If it is associated, it is already ruptured or not. Okay, that seismic history one can see, and then based on that one can be come to conclusion that there is a possibility of the bigger level earthquake. Bigger level means above 5.5, anything which harm structures. Okay, 5, 6, 7 doesn't matter. Okay, so a bigger earthquakes are possible or not. Okay, so that you can rule out, but I can see that many scientists are exchanging their view. Somebody says that there is a this may be a poor shock, a big earthquake can be expected. Big means anything which causes a damage. Somebody says that no, this is not the place where big one can expected. Big one is only expected on plate boundary, not on the interior of the plate, because the Delhi is the where the NCR is actually slightly like far away from plate, but I think maybe more than 300, 400 kilometer away from the plate boundary. They are telling that no, such big earthquake may not occur. So there are two ways we should look at it. One is that very large earthquake which has to which is expected to occur in the plate boundary. So that is like 8 and above, 7.5, 8, 8.5 and above, those kind of magnitude. Even that doesn't occur, it doesn't matter. Okay, so the next is the moderate earthquake, which is generally occur in the interior of the plate. So which is starting from like 4.5, 5, 6. Okay, so 6.5, so up to 7.5 you can take as a moderate or a big earthquake kind of in the scale. So those earthquakes occurring also trigger a lot of problem, depends upon the place and the building construction type. Okay, and then wave modification. So particularly I hope I told you that, so the 5.7 magnitude, okay, which is occurred in Tripura, okay, so in the Manu river caused very extensive liquefaction in the agriculture lake. Okay, so there are 2,500 buildings are damaged due to that earthquake, and some of the mud buildings even collapsed. There are about 2-3 fatality was identified, many injuries are identified. Luckily the epicenter was close to the agriculture area, and the liquefaction also occurred in agriculture area. So not much devastation has been reported in the urban area, but the NCR we cannot ignore like that. Okay, because the NCR is actually where the earthquakes are occurring, and nearby many urban settlements are there. It may be the warning, we should take it as a the foreshock kind of data, and try to look at a seismic signal. Okay, try to understand a seismic signal and look at geology and seismotectonic, and then study. Okay, a very quick study can be done, and then people try to report that what is the possible magnitude if at all it going to occur. Okay, if that is occurring, how the in that area what are the consequences can be expected. Okay, how much the ground motion you can expect, can the liquefaction take place or not, if that ground motion the buildings are safe or not. If it is not safe, we should advise those people saying that you take care that these earthquakes occur at any time, your buildings is not safe. Okay, so if you want to safely live, move to the other location, or do something retrofitting or something so that it will become safe. So that kind of warning at least save the life of the people around that region. But I am not very sure when you are watching this video what will happen, because you may watch this video after 2-3 months. So by the time the earthquake may occur, may not occur, we don't know. But this is how we can take is a prediction. Okay, so prediction forward informing people to reduce this one. So this is significantly similar to the prediction of our cyclone. Okay, so cyclone, what we do? So we soon after cyclone forms, so we will see that what is the speed it moves. Okay, if that comes, how which are the area going to affect. Then people accordingly will evacuate the people, and then it comes actually, then it trashes away. No? So cyclone, what happens? You are basically seeing after formation of the cyclone. So that is why the prediction, okay, the cyclone prediction, the consequences due to cyclone is you are able to understand well and also able to tell the people warning, and more or less the damage whatever prediction happens more or less is matches, except there is a slight difference in the time and a slight difference in the area, but more or less it happens. Many people life savings are happening because of this prediction. But unfortunately the earthquake doesn't do like that, because it once breaks, it suddenly reaches to the place where the cyclone takes long time, because it depends upon the velocity and distance where it forms. So because of that, sometimes this warning goes even wrong, doesn't matter, at least people aware, okay, we are in the region of this one, what to do when earthquake comes. So that kind of identity will give. So by looking at all this scenario, okay, so we need to understand that estimating and mapping up seismic hazard at a particular regions are very important for the new design as well as the retrofitting the existing structures. Okay. So this estimation again it has to be on the regional scale. Okay. So why a regional scale I am talking? When we have seen the global earthquake model GEM we have seen. So we have seen that they have considered the macro scale models and data and try to predict. So but we should do it on the regional scale, which is like a country code has to be in the regional scale, but unfortunately our earthquake code need further improvement and update. That is why we discussed that the micronization of the urban centers, okay, are under progress. They are trying to develop a zonation map of the each city, particularly people who are 5 lakh and above. So try to generate a the micronization map that will be more robust way in the future. So if you want to predict a regional level accurate hazard, okay, so what we should do? Basically we should go try to understand regionally what happens. Okay. So what are the seismicity pattern, what is the tectonic pattern, what is the geology of the region, what is the soil in the region. So that is what we should do. So in order to do the hazard estimation, okay, part of the course, so we need to understand first what is the seismicity, tectonic and geology in the India. So our class from today onwards we are going to talk about specifics to India, all these parameters, how it varies, what are the different studies I have done so far. So I try to summarize or discuss most of the studies, but what I am discussing is not only limited, okay, it is only the indication that what are the factors you should look forward. When you are going for doing hazard analysis at a particular location, you should consider all these factors, even though I may not discuss. For example, if you want to do some area which I may not highlight in my study, but since I am highlighting in general as a India, so you should also look a similar kind of studies in your region. If it is not done, even it may be necessary to carry out the study before estimating the hazard values. So we are going to discuss that from today and class onwards. So we will also look at what is the government says about the Indian seismic code. So the NDMA, National Disaster Management Authority, they are the nodal agencies basically to discuss the seismic hazard at any particular location. So they say that basically the India, as we have seen that it is divided as a 4 major zone. They say that about 59% of the land area in India liable to seismic hazard damage. So how much? 59%, it is almost 60%. So they divide based on the zonation map, they discuss that the zone 5, okay, so which is very high risk zone, area liable to shaking intensity of 9 and above. Okay. So, the zone 5, wherever zone 5 is there, basically the entire northeast region, see here. Okay. So, these are all the zone 5. So, these are all the places where you can expect a intensity of 9 and above. Okay. So, this is what you can expect. So, the another is a high risk zone. So, those are called as a very high risk zone. The another is high risk zone, which is zone 4. Okay. So, basically the orange color in the map. If you look at very closely map, so basically this part. Okay. So, then the part here. Okay. So, next to the red, and then all this part. Okay. So, a part around. So, those are all the zone where you can see these are all the zone basically considered as a high risk, where the intensity of 8 and above is expected. Intensity of 8 and above, okay, so is expected. So, the third is a moderate risk zone. So, this moderate risk zone basically yellow in color. So, you can see all these areas again, it is followed by the this one. So, this region's intensity 7 is expected, or intensity 7 is occurred. So, as I told you that this map based on the past history of the earthquake in the region. So, this is also experienced region, we can say. The zone 2, the low risk zone, so which is 6, okay, and lower can be expected. So, the overall the past seismic intensity value has been used to prepare a zonation map of the country. So, that is what we discussed. Okay. So, the considering recorded history of the earthquake in the country, that is what it's actually the message whatever I am discussing now has been taken directly from the NDMA website. So, they are written very categorically saying that the considering the recorded history of the earthquake in the country, seismologists have classified 59% of the landmass in India as a prone to earthquake of different magnitude. Okay. And 11% in the very high risk zone, and 18% in the high risk zone, and 30% in the moderate risk zone. So, the capital city of Guwahati and Srinagar basically comes in the very high risk zone. So, like zone 5. When the national capital of Delhi comes under the zone 4. Okay. The mega cities like Mumbai, Kolkata, Chennai in the zone 3. Okay. So, the Bangalore is basically on zone 2. So, about 38 cities with a population of 500,000 and above. Okay. So, and the combined population of million are located in this region. So, more than 38 urban centers are located, okay, on the different part of the this zonation, which is very risk. Okay. So, these cities need to estimate what is the expected risk in detail. Okay. That is why the micronization of Indian city, where they are basically planning on the future studies on this, combining all these 38 cities. So, the table 1 basically shows, okay, the table 1 shows. So, the region where, okay, region wise frequency of the occurrence of the earthquake based on the last 110 years data. So, here also we should note that this 110 years, okay, basically the instrumented data plus historic data. Okay, it is not the only instrumented data, as we know that the proper instrumentation in India started only after 1960s. Okay. So, this side which basically gives the seismic region. Okay. So, which are the region you can classify. The number of earthquake magnitude occurred, okay, in the 110 years are given here. Okay. So, the Kashmir and Western Himalaya. So, 5 to 5.9 magnitude, about 25 earthquakes are occurred in the 110 years. So, 6 to 6.9 magnitude, 7 are occurred, 7 to 7.2 are occurred, 8 magnitude, 1 is occurred. So, even though the Kashmir and Western Himalaya is a very active region seismically, but in the last 110 years, okay, only one earthquake was reported. Okay. So, similarly this was also very old earthquake actually. Similarly, the central Himalaya, okay, so the 5 to 5 9 magnitude 68, and 6 to 6 magnitude 28, 7 to 7.94, and 8 plus 1. Okay. So, the northeast India, okay, so 200, and the lower magnitude, the moderate actually 128, okay, so the high magnitude 18, mega earthquake 4. Okay. So, then Indo-Gangetic Basin and Rajasthan, so 14 in the moderate, okay, so magnitude. So, the big earthquake 6, so the greater earthquake nil, and this one also nil. So, similarly the Gambey, Ran, Kutch, this is a Bhuj region. So, 4, 5 to 5.9, 6 to 6.94, 7 to 7.91, and 8, 9. So, peninsular India 31, say 5 to 5.9, and the 6 to 6.10, above 7 basically nil. Andaman and Nicobar, so 80, 68, and above 7 1, and above 8 1. So, here you can see that this data whatever is reported here based on the past observations. Okay. So, people are observed this data in the past, and as well some of them may be recorded. Okay. So, sometime if you do not have any people to observe, if you do not have the seismic instrument, okay, kept on this region, then there may be chances that the earthquake occurred, it may not be noticed. Okay. So, you can also see that the number of earthquakes, okay, the smaller to this range, basically these two combinedly. So, okay, so this two combinedly will indicate that how well the seismic energies are being released in the region. Okay. If the many earthquakes are not occurring, there is a chances that the storing of energy is happening in those places. So, that is what you can see the northeast. So, you will see many earthquakes, but the west and the central there is not much earthquake. Three of them are in the plate boundary. So, okay, so these are the information which we can get from this. So, this data actually taken from NDMA website. Those who are interested, you can go and check the NDMA website and then get clarified. I hope this data they will also update, because this is quite old now. Okay. So, the overall the seismic zoning of India, country has been classified into different zone, indicating that intensity of damage, frequency of earthquake occurrence. Okay. So, this zoning map indicate that broadly seismic coefficient could generally adapted for the design of buildings of different part of the country. Okay. So, the code gives a seismic coefficient. These maps are based on the subjective estimate of the intensity. You can see subjective estimation, okay, available information of the earthquake occurrence, geology and tectonic. So, this is a statement which is made in the NDMA website. Okay, as I keep telling you that this data was taken from there. So, the Indian seismic zoning continuous process which keeps undergoing a changes as more and more data occurrence of the earthquake become available. So, this zonation map are keep updated after the earthquake, not based on the predictive hazard at a particular location. Okay. So, that is what the message we can take it from here. So, India on account of unique geophysical setting. Okay. So, the India has a unique geophysical setting. So, what is the unique geophysical setting? We will be discussing in the coming classes, and highly prone to earthquake of various intensities. Okay. So, basically it should be written as a varying magnitude, but since the code uses a intensity as a value to describe the zonation, so they also written as a intensities. So, the country has faced several devastating earthquake in the past, resulting in a large number of death and severe property damage. So, this is the evidence from many of the past earthquake. So, during the last century, okay, the 5 earthquake measuring M8 and more had struck different part of the country. So, the Great Assam earthquake 1897, Kangra earthquake 1905, Bihar Nepal earthquake 1934, Andaman Nicobar earthquake 1941, Assam earthquake 1950, and caused untold misery to the affected community and enormous damage to the infrastructure and public priorities are reported due to this earthquake. But all these earthquakes, if you see, these all occurred, okay, so more or less, okay, so before our independence. okay, except the Assam earthquake, which is soon after the independence. So because of those period, there is no seismic instrumentation in the country, which we have seen. There was only 1 or 2 earthquake instrument was kept throughout the country to record something. So the recent years, damaging earthquake had been experienced in the different part of the country. For example, Assam 1988 earthquake 7.2, Bihar Nepal earthquake 6.5, again 98, Uttarakashi 1991 6.6, Latur 6.4, Jabalpur 6, Somali 6.8 and Bhuj 6.9. So these are all the recent earthquake after 1985, where the third revision of the code 1984, after these earthquakes are occurred. So some of the earthquakes events, like the Musharrafat earthquake in 2005 7.6, Great Sumatra earthquake 2001 9.1. So even though these earthquakes are not part of India, but these earthquakes are caused severe economic and fatality damage or loss, severe economic and fatality loss to the India. So that means the earthquake which not only occurred in within Indian boundary we should concern, we should also concern that the earthquakes are occurred anywhere within the anywhere near, okay, to our country, okay. It depends upon the radius of damage which is expected to cause, okay. That is what we need to understand. So these are the some of the major earthquakes we reported so far. So we will discuss this earthquake and continue our discussion in the next class. So we have been discussing about the seismicity of the India, because the understanding of seismicity is very important to predict seismic hazard in the region. Without understanding the seismicity and past earthquake, you cannot predict a earthquake hazard precisely in the region. So with that aspect, we are discussing the seismicity of India. We will continue our discussion in the next class. Thank you very much for watching this video. So we will meet you in the next class. Thank you.